Hello everyone. Today I'll be going through the final two questions of the 2019 Math Methods Exam 1. So obviously, because they're the two final questions in the exam, they are pretty hard. But yeah, let's get to it. So for question 8, part A asks us to find the rule of f. So notice how I've drawn 3 points here. So through these 3 points here, it should tells us that they represent these respective features of the graph. So if anyone has any question regarding that, please let me know. But other than that, we know that these 3 features must be in our graph. And what a lot of people forgets that there is a dilation at the front, and I just use the letter A to represent that. So yeah, we can't forget that there can be a dilation in front. So to work out the dilation, we sub in the point given, which is shown here, and we get A is -4. Then we get our graph is this basically. The next question, this is a really tricky question, and it asks for our domain for this h of x function here. So notice how the h of x function is composed of 2 logarithm functions here, and we know that the domain of log is from 0 to infinity. That just implies that the range of g of x must be capped to 0 to infinity. And the range of x cubed plus x squared must also be capped to 0 to infinity, with 0 being non-inclusive, of course. So, and of course, because we're looking at this function as a whole, at the end, we have to take the intersection of these two range, because we have to have both range that works, basically. So now if we look at this graph, right, we know that we can accept values from 0 non-inclusive to infinity. So for this part here, we obviously see that this part here and this part here is accepted, basically. In other words, it's from -1 to 1 non-inclusive, and we also have to exclude 0, because at these points here it touches the axis, of course. And regarding x cubed plus x squared, we can write it as this, so x squared bracket x plus 1, and then a quick plot, which is shown here. So I guess I'll kind of zoom in a little bit. This is the quick plot of the graph, so it would look like this. So we go up like that, and then we go up like that. So we know that for this graph, it's from -1 to infinity, excluding 0. That's the part where our range is accepted. So we have these two respective ranges here, and we need to take the intersection, and the intersection is just this. In other words, this. Yeah, and that's why that's the answer to this question. Okay, the next question, this is even trickier. We need to find the range of h. So first of all, we can combine the 2 logarithms, and then we simplify it to this. So in fact, I can rewrite this as log e of 4 of 1 minus x if I want. So if that might look a bit neater. So these two are the exact same thing, it's just rewriting it. So hopefully everyone knows how to get from this step to this step here, and I've shown my working out here anyway. It's just canceling out top and bottom, basically. And also we have to know that our x is, this is our domain for x here. So what we want to focus here is we want to focus on the inner parts of this, aka this thing here, in other words, 4 minus x. And if we try to plot this 4 minus x graph here with this domain, it will look like this, right? This point here will be, well, -1 and 5. This point here will be 0 and 4, and finally 1 and 3. And notice how all these 3 points are excluded, basically. So now we focus on these points. So for the top point here, as x is approaching to -1, we know that the range of h is approaching to log e of 8. And how I got that is, if we sub in -1 here, we know that this value is log e of 8. So as x gets closer and closer to -1, the range will get closer and closer to log e of 8. Okay, now we focus on when x is approaching to 1, aka down here. So we know that as x is approaching to 1, the range of h is approaching to -infinity, right? Because as x is approaching to 1, this inside value here becomes really small, and a log of a really small number is basically approaching to -infinity. And finally, we know that since x can't be 0, then the range can't also be log e4, right? Because if we sub x equal to 0 here, we go log e4. And after we put these three pieces of information together, this is what we get. It's from negative infinity to log e8, but we exclude log e4. Yeah, so obviously these two are very tricky questions. If you look on the report for them, like 1% of people in the entire state got them right. So yeah. Okay, anyway, on to question 9 now. Question 9, arguably, I think the final question for this is even trickier, but first we look at the ones before first. So g of x, this should be relatively straightforward. That should be the answer here. If there's any questions regarding how do you work this out, please let me know. Part B, we find a derivative. And we want to find values of x such as the derivative is negative. So we know that if we can kind of divide a derivative into these two parts, we know that e of this part would never be negative. That's why we have to focus on where this part is negative. So 2 minus 2x is less than 0, which means negative. And after that, we just get x is bigger than 1. And that's the answer for this question. F of g of x, again, this should be relatively easy here. And solving that for 0 should be is one of those disguised quadratic equations. We just let u equal to e of x, substitute that in, and then after we factorize it, we either get u as 3 and u as -1. But we know that u can't be -1 because if u is -1, this doesn't make sense because u is equal to e to the power of x, and e to the power of x is always bigger than 0. So as such, we know that e to the power of x is 3. In other words, x is log e of 3. And next question is asking for find the coordinates of the stationary point of that. So again, we take the derivative, we make the derivative equal to 0, right? So 0 is equal to this, and the only possibility is that when x is 0, this part would be 0 because 1 minus e to the power of 0 is 0. And of course, after we sub 0 into f of g of x, we get 0, 4 as our stationary point. Okay, so now we go on to the final question. Yeah, so this is a very, very tricky question. As you can kind of see here, I have a lot of stuff written down. So instead of looking at the question like this, the way I did it, and I would like to say that there's no, like, I don't guarantee my method is, in fact, I don't think my method is nowhere close to the best method. It's just how I thought about doing this question. So I did this question, instead of writing g of f of x plus f of g of x is 0, I write g of f of x is equal to negative f of g of x. And I'll show you why I did this later. So first of all, let's look at what we know about our graphs. So for both graphs, g of f of x and f of g of x, we know their rules, of course. And then we go down to two different parts. The parts that questions before tell us, and there's going to be things that we have to work out ourselves. So for example, right, by working out questions before, it tells us that g of f of x is, well, strictly decreasing after x is, like, when x is bigger than 1. And it has a stationary, and from that we know that g of f of x has a stationary point at x equals to 1. And this you can also verify it when we go above to here. When we sub 1 into this, it gives us 0 basically. And what needs, like, I guess, further investigating for this graph is actually kind of its gradient map here. So we know that at 1 is a stationary point, after 1 it goes down. Then before, if we're starting a value smaller than 1, we know that it will go up. So this is kind of like the gradient map for g of f of x. So we know that it goes up until 1 is a stationary point, then we go down after. Okay, cool. And the final thing, which is, I guess, the hardest thing to realize about g of f of x, is that it is always bigger than 0 because it's e to the power of something. So e to the power of something can never be a negative number. And that's why we know that this function is always bigger than 0. Okay, now we look at the f of g of x, and this one is much harder to analyze than g of f of x, in my opinion. So the question tells us it goes through this point here. It only has one stationary point, which is 0 and 4. So in fact, and then we can also work out its gradient map by subbing values bigger than or less than 0, and it has the same gradient map as that. So if we kind of try to graph f of g of x right now, we know that it goes to this point here. So this is its stationary point, 0, 4. And we know that this goes through this point here, 0, sorry, that's log e of 3 and 0. And that goes down, right? But the question didn't really give us any information of how the left side of this graph goes. And I think here is arguably the hardest part about this question. And let me just erase this quickly. To figure out how the left part about this graph goes, we look at these two terms here specifically, 2e of x minus e to the power of, this meant to be a 2x here. I don't know why that wasn't down there, so let me just add that in. Okay, and think about it. If we have a number that is really, really, really big here, like, I mean, like very, very big negatively, then this number is going to be a very, very small number, right? Because each power of a very big negative power will give us a very small number. But this number would always be smaller than this one because it's 2x compared to x, right? So this is definitely much smaller than the first term here. So because of that, we know that when this minus this, it will always give us a positive number, but it will be a very, very, very tiny positive number. So basically, as x approaches to negative infinity, this part approaches to 0. And we know that this entire graph in the negative end would approach 3. So in a way, it actually looks like this, where there's kind of like an asymptote here at y is equal to 3. See, this is what I mean by, like, I guess that's probably the most trickiest part about this question, is to realize that on the negative end, it has an asymptote at y equals to 3. So after we know how this graph works, I think graphing the other graph is much easier, right? So the other graph is, I guess I'll switch another color here, is this graph here. Because we know it goes up at one side until it reaches 1 and e to the power 4. And then we're going to go down. And we know that this graph is always above the axis. So this is kind of like its shape. So, and of course, this blue graph here is our f of g of x graph. And this is why at the start, I decided to do this equation as g of f of x is equal to negative f of g of x. Because if we now just reflect this curve here in the x-axis as shown by this red curve here, we can clearly see that there is one intersection point, and that is the answer to this question. Yeah, so obviously this is a very, very, very tricky question. So, and I mean, it is the final question in the exam, so it's completely normal that if you don't get this one correct, but just make sure when you see questions like this, always take a guess, right? Because it says state the number of solutions. So it's like, it's not something that's like entirely impossible to guess. So yeah, make sure we just don't leave it blank, I guess. Yep. So if there's any other questions regarding this, please let me know. And other than that, I'll see you all next week.